Welcome to Open Source Spotlight. We invite open source authors and ask them to show the tools they are working on. Today we have Tomas. Hi, Tomas. Tell us a few words about yourself and about the tool you want to show us.
Hello, everyone. So I'm Tomas Neubauer. I'm CTO and co-founder at Quix. And my background is in software engineering, and I have spent pretty much my whole career working with real-time telemetry data coming from devices like vehicles and basically things around the world out there. And for the last 3.5 years, I have been working on an open source library called Quix Streams, which allowing Python developers to leverage stream processing and technology like Kafka. And today I want to show you an example of that, how you can use it for a use case of cyclist having a fitness app on the handlebar and crashing with its bike, and using a machine learning model to detect that crash and immediately notifying emergency services and family about that situation.
What is exciting for me about this demo is I know how hard to use Kafka in Python. So typically, if you want to use Kafka, you need to use Java or some JVM
language, of course.
Right?
Yeah.
So yeah, I really want to see the demo.
Yeah, cool. So first of all, I'm going to show you how I'm going to get the data, and then I'm going to build the Python service with the machine learning model. I already trained the model. We're not going to be able to do that today. So first, I'm going to share my browser, and here I have prepared a microservice which has a front-end application that would serve as a visualization of our model. And then I'm going to start the application on my phone, which is also open source. You can find it on our GitHub, and you can do whatever you want with it. You can rebuild this demo or just change it to something else, do some home project. And here I'm just going to add a WebSocket gateway, because Kafka is not really good to connect to end devices. Don't use it for that. You will quickly end up with a problem. So now we have this gateway, and hopefully there we are. We're getting data from my phone, like GPS, speed, altitude, but most importantly, information from G-force sensors. And we're going to use them today. So now we are in a good position to start building a pipeline here, and I will switch to my IDE to show you how you can use QuixStreams library to basically build a new block in this pipeline. So I'm using PyCharm. There we are. So this is like an empty template that you can think of for a pub and sub service, which you can build with this library. And this library is all about stream processing, and pub and sub service is the main concept to grasp if you're going to approach real-time pipelines with this library and this way of doing things. It might be resemblance to Kafka streams, and that's because it is. It's just built in Python. So first, I'm just going to run this, and this sprint should give us information that we actually have a data. There we are. So you can see there's 3 streams because I ran it as a test before the start of this meeting. And so we're having data in our Python, so we can start building. Now, what we have done here is basically it's attempt to vilify streaming in a way and reduce the barrier for people coming from batch and for data scientists and ML engineers used to work in Jupyter Notebook with static data into streaming, because streaming is quite a different animal, and a lot of concepts just simply change for you, and you have to do it differently. So here, I'm going to get a data frame from input topic. Now, you might be thinking how you can get a data frame from a topic. Obviously, you don't, because this is streaming data frame. It's a virtual frame, which is going to have virtual rows. And what that basically means is we're going to get data flowing through our data frame. rows flowing through our data frame, to be specific. Sometimes message will contain one row, sometimes it would contain 5 rows, depends on the granularity of the data source. We don't really care. We care about what we're going to do with this data. So the first, what I'm going to do here is just a projection, because I don't need all the columns in this frame. So let's use just 3 columns like that. And let's print the hat. And then I'm going to do a loop of this frame and print the rows. So if I if I press play, I will get a virtual table that if I scroll to the top, we have timestamp. Now, timestamp is a first-class citizen in this library, and it's not just another property in your JSON. It is more important. It serves as a primary key. And then you have GeForce X, Epsilon, and Z. And if you go down, you will see now if I shake with my phone, the data going haywire because GeForce sensor being triggered. You see some nuns because not all rows have this data. And for that reason, I'm going to do filtering here. And in a typical pandas fashion, that's going to look like this. And now let's start with the stateless operation, sometimes called one message at a time processing. That's the easier one. And that's why I'm going to start with it. Now, our machine learning model expects a 4th column, these 3 plus a column called GeForce total, which is just a vector from all dimensions to get a total amount of forces applied to the device on the handlebars. Because sometimes you have phone in a landscape or portrait, you don't know how the person would put the phone on the handlebar. So we're going to get a GeForce total column in our frame, and it's just going to be an absolute value of all 3 columns. And I'm just going to copy paste with a plus. There we are. Now, because we might get over the column, sorry, the width of the console, let me just set a different width here, and let's put play. So now we have another column in our frame, and this column we're gonna get 9.9 Gs. That's correct, because that's the gravitation forces of this planet. But if I shake, you see it's going up and down. So that's working. So now we have done a stateless operation where each output of this function is dependent only on the row that we're working on. But let's do something stateful, a bit more complicated. That would require working with the state, working with the values that were previously streamed into the system. And that's where it gets actually complicated, and that's why this library exists. Because to get this right, it's a hardcore software engineering and also understanding very well how a distributed system works, like Kafka and Kubernetes, because you need to scale your transport and compute at the same time. So that's what we're doing under the hood. So here, let's say I want to track the last 10 seconds average, a rolling average of last 10 seconds forces applied to my phone. And so for that, we're not going to do anything new. Again, we will just use a typical pandas way of doing things. So here I would create a GeForce total 10 seconds. And I will get this new column, and I will get 10 seconds mean. And now, if I press play, we get yet another column. And you can see that if I now start shaking, it will slowly go up. If I do that for some time, it will go up. And if I put it back to the table, it starts going down. But look, what if I stop this service? Now, what we need to make sure is that we're not losing this state. We are not losing the number 14. So when I press play again, this service will make sure that we continue where we stopped with the state. So you see, we're starting from 15 and going back to 14.12. So we have not missed that window when my code was not running. And that's super important because you might get a hardware failure on your underlying infrastructure. You might be rolling a new version of your code, or you just might have a bug in your code. You never know. And this is where we do it resiliently, but also in a scalable fashion. So this library would stick the data to partition in a way that you can then run this code 5 times, 10 times. And you don't have to change a single line of code to make that code work in a group of instances when you get more than just one phone. So that's how we get a stateful processing. And the last bit I want to show you today is how you're actually going to plug the machine learning model. So here we have, I have a machine learning model that I already trained, or my colleague already trained before. And I'm just going to copy paste some code, which will load this model from Blob Store. Now you can use any sort of model registry. That doesn't matter. This is a TensorFlow model exported to the pickle file. And this is where I want to talk about the biggest advantage, I believe, in this way of doing things. Because this is just a Python, you have the whole ecosystem of Python at your disposal, which means you can use anything from pip. You can actually even edit a Docker file under the hood and add, you can use OpenCV library, for example, for computer vision to extracting frames from videos. It is flexible way of processing data. And you can use mathematical and statistical functions from different libraries as well. Then this is how I'm going to call my model. So let me just fix the indent. There we are. So again, this is the 4 columns that this model expects. And the last thing I just need to do is go here and do a shaking column. This is the name of the column that our microservice is going to expect. And then I'm just going to do apply, predict, and we are done. But to make this output of this model landing in my front end, I need to do one last line of code. And that is sending this information to output topic. And that's just going to be as easy as this. And we are done. So this model will emit 0 if there is no crash, and will emit 1 if there is a crash. And we can check that first in the console. And in a second, I will show you the result in the front end. So here we are. And if I now take my phone and shake with it, it's getting numbered once. Now you might be asking, well, I'm not crashing my bike. Well, of course I don't. So we have trained this model actually to detect shaking, not crashing, because for just practicality reasons. So now I'm going to stop my share and go back to my workspace. And if I now go to my microservice here, this is using the same WebSocket service I created in my workspace. And you can see I'm in Prague. And now I shaked, and you see that immediately I'm getting this event from that machine learning model. The actual latency is a round-trip journey of 40 milliseconds. So when I'm crashing on my bike, and this front end knowing about this is less than the human eye can actually feel. So I hope you like it. I hope it was clear. And if you want to give it a try, go to our GitHub and just pip install Quix Streams. And this frontend that you're looking right now is also in GitHub in different monorepo together with this Android app. And yeah, so feel free to give it a try. And thank you for watching my demo.
That looks so awesome. I was like speechless all the time. I did not want to interrupt you. So we will make sure to include all the links. It's been a while actually since I visited Prague. Very nice city. So I have a few questions for you. So how many people are working on this library?
So as a company, we are 35 in terms of engineers. I think it's 4, sometimes 5 people working on this, only on this one library right now.
If somebody wants to contribute to Quix Streams, what do they do? How do they go about this? Is there a contributing guide? Are there good first issues?
There is. And first of all, I want to say that it's not the only open source library you can contribute on our GitHub. There is all of these connectors and things. They are all open source, and they are actually when the PRs are merged, used by our platform as well. So yes, there are contributing guidelines, and we are very welcome to any contribution. And there's lots of space where we are planning to ask for contribution. So these streaming data frames, obviously, there's a lot of API in Pandas that we can't possibly implement by ourselves. So we're just gonna share a guideline how to implement custom functions, and people just can, for their use cases, for example, implement just one they just need.
So if somebody wants to contribute, they go to your organization in GitHub, select the project they want to contribute to, open it, and then there is contributing MD, I guess, file, and then they look there. Do you have like a community or some sort of forums where people can ask for example, I want to contribute, but I don't know where to start, like which project to start, where you need most help with. Like maybe I can just go somewhere and ask you to give me some guidance.
Yes, sure. So, well, first of all, we until now had a community Slack where we were discussing all of this. We are launching a forum as well, where for some people might be easier to use. We also have a meetups where we try to kind of get the community together. These meetups are all around the world, but mostly in Berlin, Munich, and London, and new cities will come soon. So if you are in these locations, come to the meetup, have a pizza, and we have speakers talking about stream processing and real time in general.
There's one in Berlin like next week, right?
It was this week actually.
Okay.
It was amazing. By the way, all 3 speakers.
I missed it.
Yeah, all 3 speakers really. It was. I really like it. And the next one is at the end of this month in Munich. So 30th of May. That'll be next one.
Yeah, that's pity. I thought it's actually next week. Well, I'll make sure I don't miss the next one. So you mentioned that you have some plans. So you have this streaming data frame, and it's very difficult for you to implement all the Pandas API. So that's one thing you need support with. Do you have any other plans?
Yeah. So well, this library roadmap have a different format. So like, for example, Ever support and others. Now, we also are planning to support different brokers. So the idea is that you can swap between Pulsar and Kafka, and you don't have to actually change a single line of code. And also others where possibly the API is different, but because not every broker will support Kafka interface. And then what we're working right now is actually, I think, quite exciting thing, which is a support for MATLAB and Simulink. So this library background is obviously telemetry, and we're really coming from this type of industry. And Python is quite important tool, but MATLAB and Simulink as well. There's also open source alternative of MATLAB, which we're going to support as well. And so the idea is that you can use the Python and your functions together. So maybe you want to migrate to Python, but you still have some functions. It could be the case. Now this would just smooth your migration to Python.
Really curious. It's really interesting that you mentioned MATLAB. I'm wondering like how many libraries are there that you can actually run Kafka in MATLAB. Maybe not so many, right?
I don't think many of them. That's but
like, is there at least one? Well, there will be soon, right?
So it is you know,
it's like a different world.
Yeah, it's a different world. Very hard to, you know, the tool on itself. It's very difficult to integrate with. So our aim is to make it super simple and you know, make the use of old functions that you might create in this world, and also using the function of the new world. You know, imagine you want to use something from the new Python libraries out there for physical world, but it's not like black and white. You can't just switch from day one to day two. And yeah,
I guess in this case you would have multiple topics, right? So one would listen to a stream in MATLAB, do some processing, put to another stream, right? And then there could be a Python library that reads from this output stream and does some extra processing.
So the way how we approaching this is that we run MATLAB in Docker. And so our library works with Docker very well. There's the last line, there's a lot of logic for graceful shutdowns, things like that. So we would inject the address of licensing, and then the MATLAB would authorize yourself. And then that's obviously not the case for the open source version of MATLAB. You don't need to do that. And then we receive the data in Python, and we call the MATLAB function, and we get the result back to Python, and we output it. So what you see today with my TensorFlow example, just imagine that it's not TensorFlow, but MATLAB function. It will work exactly the same.
That's really cool. Okay, last question. Do you have any advice to anyone who's watching this?
Well, if you are a data scientist or ML engineer working with batch, this is the next generation products that we're gonna build in the future. So by learning this, you're just getting ahead, and it's also very interesting because suddenly the things around you are affecting your code immediately, and it's very addictive to work with the real-time data. Going back to batch, it's gonna feel a bit boring. So I really recommend everyone to give it a try, and actually really recommend to work with something that you can in your development work with, like sensors, temperature sensors, or the phone or something, because it's just a bit more exciting than to work with some arbitrary data somewhere.
Yeah, great. Thank you. That's all for today. Thanks a lot for doing this great demo. It's a really nice demo. Thanks for doing this, and looking forward to seeing more demos from you in the future.
Yeah, so thank you for having me, and have a great day. Bye-bye.